CDC WONDER is a query tool from the Centers for Disease Control that provides access to a collection of online databases for the analysis of public health data. The following are a sampling of databases from the organization I work for, the National Center for Health Statistics. For this example, we're going to focus specifically on the detailed mortality database, which provides counts for deaths and rates, accrued or age adjusted, for underlying cause of death. Let's take a quick look at the query tool itself. I've set up a query that groups the results by year and race, includes these three age groupings, and limits the cause of death to diseases of the digestive system. Here's an example of the data output from that query. You can chart that data within the WONDER system. And also take note that group by variables span multiple rows in the table, and that'll be important when we parse the data later from the API. WONDER provides an API that allows the same queries to be issued through a POST request to WONDER's web server. Requests and responses are issued in XML format and are detailed in the API documentation page, seen here. Each XML request consists of a series of parameter tags with name and value children in the following format. The detailed mortality database contains dozens of parameter names and values, and a full listing can be found on the CDC WONDER wiki page. To simplify the creation of the XML request in Python, we've set up several categories of parameters. This page shows the by parameters, which designate how the data from the resulting query will be grouped. Here you can see that we're passing the values for year and race into the by parameters. These are the measure parameters, which specify which numeric measures will be calculated in the resulting dataset. By default, deaths, population, and accrued rate must be included. We've also included here standard error and 95% confidence interval. The F parameters specify values selected in Finder controls on the query form. A limitation of the WONDER system is that data cannot be grouped or filtered by location-specific parameters, such as state, HHS region, or census region. Those must be set to all. For this example, we wish to limit ICD codes by the category for digestive diseases, which is K00 through K92. I parameters are the contents of the currently selected information window next to the Finder controls. Here we show the full description for what's currently selected when we select diseases of the digestive system. V parameters include variable values to limit in the where clause of the query. Here we've selected age groups 15 to 24, 25 to 34, and 35 to 44. O parameters indicate other options that may be specified in the query. A couple things I want to note here. Notice that age-adjusted rates are included via the O parameter rather than the measure parameter. The type of age grouping used within the query can be specified here through the OAge option. I've specified 10-year age groups. The type of location variable used in the query can be specified through OLocation. I've specified state. Level of precision, or number of decimal places, I've set to 1. And the rate per is set to 100,000, meaning deaths are calculated per 100,000 persons. The VM parameters specify some options when selecting non-standard age-adjusted rates. Since our example includes standard age-adjusted rates, we'll just leave these to their defaults. And finally, the miscellaneous parameters specify a number of standard options that are normally hidden from the user in the web form, and these do not change. Now let's bring it all together. We have a helper function here, which when given a parameter list dictionary object, will create one or more parameter tags with a name and one or more value tags included within that parameter tag. And the full list of parameters will be returned as a string. We can then create our XML request. We begin by adding the request parameters opening tag. Then we use our helper function to append each list of parameters to the XML request. And finally, we end the XML request with the closing request parameters tag. Then we import the request library to facilitate the HTTP post request. For that, we need our URL. So here we have the URL to the API endpoint for the detailed mortality database. And we'll pass our XML request as well as a parameter which indicates that we accept the data use restriction policy. Once that request is processed, we can then store the data to this data variable. Next, we import the Beautiful Soup library for XML parsing and pandas for data frame creation and manipulation. We then create a helper function called XML to data frame that takes in the XML response, finds all of the rows for the data table within that response, and then creates a two-dimensional array. Cells within the table may either be string or floating point values. Recall from the initial query created that there may be some labels for grouping variables that span multiple rows, and that's indicated through this R attribute for the C tag, which indicates how many rows are filled down with that label. The XML to data frame function accounts for this, and when it encounters an R attribute, it fills that value down for the number of rows specified. All records are returned as a two-dimensional array. A two-dimensional array is returned by the helper function and is then passed in to create a pandas data frame, also specifying a list of column headers. Here you see the first 5 rows of the resulting data frame. Using the pandas and matplotlib functions, we can then aggregate and visualize the data as desired. In this example, we group the data by year and present the total number of deaths from digestive disease in the United States. We can also create multi-line charts. Using the subplots function, we store the figure and the axis that will be shared among all the lines in the chart, and we iterate over each group in the data frame, creating a line on a common plot. To create a new query, we update relevant parameters, and in this sample query, we're going to group by year, month, and cause of death. We are including cause of death codes dealing with drug overdose deaths, and we are revising our age groups parameter to include all age groups. We then, in a similar manner, create the XML request, issue that request, and then create the data frame using the two-dimensional array returned from our helper function. Again, we can aggregate and visualize the data as desired. In this example, we group the data by year and present the total number of deaths due to drug overdose in the United States. And in our final example, we group the data by year and cause of death, pivot that data frame on the year and cause of death fields, presenting number of deaths, and we can create a stack area chart, which shows the distribution of drug overdose deaths by cause of death over the years. Using pandas and an assortment of data visualization libraries in Python, you can create dynamic reporting and data visualization dashboards that ultimately go beyond the capabilities of the CDC WONDER system.